Have you ever really thought about what happens when you flip a light switch? I mean, what's really behind that simple click? Well, it's not magic, that's for sure. It's actually a super complex story about fuel, technology, and, you guessed it, a hidden carbon footprint. Let's dig into that. So, right off the bat, is all electricity created equal? The short answer? Absolutely not. The power that's charging your phone right now has a specific carbon footprint, and it can be wildly different from the power someone else is using just a few hundred miles away. So how do we even begin to measure that difference? We use something called an emission factor. Honestly, the best way to think about it is like a calorie count for electricity. It tells you exactly how many kilograms of CO2 get pumped out for every single megawatt hour of power we generate. Simple, right? The higher the number, the dirtier the electricity. All right, so let's meet the main players on the grid. We're going to check out their emission factors, and we'll start with the real heavyweights of the fossil fuel world. Okay, on one end of the spectrum, you have coal. It's kind of our baseline for high emissions, clocking in at a huge 1,000 kilograms of CO2 per megawatt hour. Then you have natural gas, which is obviously a lot cleaner, but hold on, look at that range. It goes from 410 all the way up to 600. That is a massive difference for the exact same fuel. So what gives? How can this same fuel have such a different carbon footprint? Well, it turns out it's not just what you burn, but how you burn it. It really all comes down to the technology inside the power plant. And that brings us to a tale of two turbines. You see, the way you generate power from natural gas makes a world of difference in how efficient it is, and that directly impacts its carbon footprint. First up, you've got your simple cycle plant. It's simple. You burn gas, it spins a turbine, and you make electricity. The problem is, all that incredibly hot exhaust gas, it just gets vented straight into the atmosphere as waste heat. That's so much wasted energy, which is why its efficiency is pretty low, only around 30 to 40%. But then you've got the combined cycle plant, which is just way, way smarter. It does the same first step, burns gas, spins a turbine. But, and this is the genius part, instead of just wasting all that exhaust heat, it captures it. It uses that heat to boil water, create steam, and spin a second turbine. You're getting two bursts of power from the same amount of fuel. It's like a buy one, get one free deal on electricity. And here's the payoff. You can see it right here. That inefficient, simple cycle plant, that's what's hitting the high end of our range, around 600. But this super efficient combined cycle plant, it drops the emissions all the way down to 410. The big takeaway here is that the same exact fuel can have a completely different climate impact, all depending on the tech we use. Okay, so that's all the theory. But what does this actually look like in the real world when an entire electricity grid decides to change its fuel mix? For that, we're going to look at an absolutely fascinating case study from Alberta, Canada. Just look at this chart. It tells such a remarkable story. Back in 2015, Alberta's grid was about half coal, that giant red block right there. But just watch what happens as the decade goes on. The red just vanishes. It's completely gone, replaced by this huge surge of blue natural gas and, of course, the green and yellow renewables. I mean, that is a complete energy makeover in just 10 years. So this begs the question, right? What did this massive shift in fuel actually do? You're swapping out one major fossil fuel for another and adding in renewables. That's got to have a pretty big impact. A huge impact is an understatement. As that coal was phased out, the carbon intensity of the entire grid just went into a freefall. The connection is impossible to miss. It's crystal clear. As the coal went away, the grid got a whole lot cleaner. And the numbers here are just staggering. In 2015, the grid's intensity was 0.76 tons of CO2 per megawatt hour. Fast forward to 2025, and it's projected to plummet to 0.42. That's a nearly 45% drop in carbon intensity. It's a massive win for the climate, and it was driven almost entirely by one single decision: get off coal. Now, Alberta's story is incredible, but it's just one piece of a much larger puzzle. When we zoom out and look at the whole country, we see this amazing patchwork of different energy systems, and each one has a very, very different carbon story. So this table shows the carbon intensity for each province in Canada. Now, a quick heads up on the units here. They're in grams per kilowatt hour, but don't let that throw you. 1 gram per kilowatt hour is the exact same as 1 kilogram per megawatt hour. So you can compare these numbers directly to the power plant figures we were just looking at. And wow, are the differences huge. On one extreme, you have Quebec, with an almost unbelievable intensity of just 1.9. I mean, that's practically zero. How is that even possible? Well, the province runs almost entirely on massive, zero-emission hydroelectric dams. Then you've got Ontario, another low-carbon powerhouse at just 59. What's their secret weapon? A huge fleet of nuclear power plants, which, just like hydro, produce enormous amounts of electricity with zero direct emissions. But then we go to the other end of the spectrum. Way, way up there is none of it, with an intensity of 800. That's even dirtier than our inefficient simple-cycle gas plant. And the reason for this is that its remote communities are off the main grid, so they have to rely completely on burning diesel fuel for local power. Okay, but there's one last, kind of hidden piece to this whole thing we haven't talked about yet. The emissions don't just magically appear at the smokestack. The story actually starts long before any fuel ever gets to a power plant. This is what we call life cycle emissions. You have to account for everything: the mining, the drilling, the processing, the transportation. And when you do that, the carbon footprint of both fuels gets bigger. For coal, it adds about another 4.5%. But look at natural gas. The upstream emissions, including things like methane leaks, add a really significant 18% to its total footprint. It's a huge reminder that the true impact is always bigger than what you just see at the power plant. So from the type of turbine used to the specific mix of fuels in your local area, the carbon story of your electricity is way more complicated than you might think. The next time you flip that switch, maybe you'll think about the incredible journey that power has taken to get to you. Now you know what powers the grid, so what's powering you?